Okay. So, whoops. Okay. All right, now we can go ahead and get started. So what I'm going to do is I'm going to share my screen. Just let me know if you have any questions or anything. I'm kind of just going to go over some basics, and we will see what happens. So my plan today was basically, I don't know if anyone was going to show up, but even if nobody did, I was going to do this anyway. So I'm just going to show the basically starting from nothing. I went and just uninstalled everything off my laptop, and how to get Python, what version you want to install, and maybe a couple recommended books, and maybe like the first couple chapters of a couple books if we have some time. So first thing to do is get the software. So I am going to go to the Python website, and here we are. And should be pretty good here. We just want to go to the download page. Apparently the newest version is 3.8.3. So there's a big giant download button, which I'm going to click on. Actually, if we were really interested, there are a couple different, go to this page here, scroll down a bit, you can see that there's all these different versions of the latest version. So you have Linux versions, you have Mac versions, and then various different Windows versions. So if you weren't sure, then you know you want probably, if you're running Windows, you want one of these. And then, okay, so the first one's a help file. The next one's an embedded zip file. This is like an embeddable zip file. It's like if you've already written an application that is going to rely on Python that you want to distribute somewhere else, then you want that one. The one we want basically is just the Windows x86 or 64-bit, either one, executable installer. So I'm going to download this, and if it takes too long, I've already actually pre-downloaded this. So then we'll skip that part. I'm going to call this. Let's see how long this is going to take. Oh, okay, we're already done. So the next thing I'm going to do is open this and launch it, and this did actually take a few minutes when I ran it the other day, but so let's get it started right away, and we'll talk about other things while that's happening. Okay, so actually first, what I kind of like to do with these is, if you're on Windows, right-click Run as Administrator, and I like to install this for all users, and I don't know if you're able to see, I got just a like a UAC prompt came up for me. So install for all users, I think, is easier because, well, let's just go to, I'm going to check both these options on and explain them in just a minute. And I'm going to click this Customize button. And okay, this is good. This is all good. All users, okay, good. And okay, so install for all users again. You'll notice this changes the install path, which to me I think is just more easy. This long path that they give you is like, I'm never going to remember that long path. To me, it's easier if it's just in like C/Python or C program files/Python. Okay, associate files, shortcuts, add path to environment variables. This one I think is helpful too. It'll just make it so that you can type the word Python anywhere from a command prompt, and it'll launch, you know, no matter where it's actually installed at. These last two, not sure that we need those. So I'm going to click Install, and that's going to run for a couple minutes. But basically, to me, that's that a lot of those little options will come in handy. So that's that. Moving on. Okay, so we don't need the website anymore. The next thing I was going to do while that's running, okay, which version differences? So the latest and greatest I think is great. There's, I don't know, sometimes you read stuff about Python 2, it's saying like, you know, there's a lot of applications that are still running on Python 2 and Python 2, but I always say go with Python 3 for everything. Latest and greatest is good, 3.8.3. There's some like the difference is, like, some of the syntax and some of the commands changed, and if you're not supporting Python 2 stuff already, then I think Python 3 is better. So that's it. So this is installing. Looks like we're about halfway done here. And this is going to be, installing the Python, all the libraries and everything, and the idle editor, which I think is development and alerting editor, and which is sort of the IDE for Python. I mean, you could type a lot of this stuff in like Notepad and run it the same way if you wanted to, but having an actual IDE editor will, see where this is at, will, oops, wrong one, will help. Just because it'll, it'll fill in certain pieces of code for you, it'll highlight things, make things different colors. It'll just be, if you're writing a lot of code, it'll be easier to do most things. Oh, and yeah, so that option with the path, at least in the Windows world, there's in system properties, which I don't know if I need to show or not, there's something called environment variables, and basically it's adding the path. In our case, it was C/program/file/Python3 something. That string gets added to the path. So whenever you type a command from just command line, you can, it will use that. It's easier in an example. As soon as this gets done, I'll show you that. So this is standard library, and we will let that go. If you have any questions, let me know. I am recording the thing too, so if you're camera shy, then you can. It's okay. You can be quiet or remain quiet if you like. So let's see. So after this will be, well, since this is still going on, we could talk about some books. Let's see, we have, I don't know, at least at the Blue Island Library, we have a number of different books available. This Python Crash Course one is pretty good. That one's at the library right now. I was going to bring it home with me, but I left it at the library. There's a lot of, there's some, of course, there's some kids ones, and then there's some that are just developed toward Python on like Raspberry Pi and Arduino and type stuff like that. There's a number of course, about Python programming instead of Python programming. There's another book that was really good. Didn't actually see this one. Apparently it's at the library though. I'll have to take a look at that one. Raspberry Pi. There's another really good book that's at the library too, but that's not the one that we're going to be using today for the program. The one that I actually want to use is this one called Automate the Boring Stuff, which we don't have a copy at the library, but it's available. There's like at least like 20 of them in the system. So once delivery starts back up in a couple of weeks, hopefully we'll be able to get those. And the good thing about this particular book, this Automate the Boring Stuff with Python, is it's completely available online. So if I just do a search for this, this is by Al Swigert, and he has put it on his website as part of Creative Commons, so you have everything here. So mostly, at least today, I'm going to work out of this book. It's a very good book. It's reviewed very highly on, like if you go to Amazon, you'll see a million reviews on it, and it's rated very highly for good reason. And luckily, it just happens to be completely available online, so if you can't get it from a library and you don't want to buy it from Amazon or something, the entire thing is here. So Okay, setup was successful. Great. So let's see what happened. So that's installed. Now, if I go to my start menu and try to find out what's here. Okay, so it gave me a little Python folder, and it gave me 4 things. So idle, the integrated development and learning environment. I think I got all that right. Which I already talked about is going to be our already, that's where we're going to type our code, basically. The actual Python itself, the interpreter, manuals, and more documentation. So the bottom 2 we don't really care about. The top 2 are really what we want to use. So if I just launch the first one, I'll get the idle editor should come up. And we would probably be doing most of our code in that. Now there's a couple other IDEs that you can get, and I can't remember any of them at the moment, but there's a number of different ones that you can get. And I mean, you could even use Notepad and it would work just as well to run the code later. So here we are, and this is basically either, you can type, as we go through some of these examples, you can type all the code right there, or you could type it in a file and then, edit it and launch that later. You could, the other thing is let me go back to, before I get too far ahead, is the, just like the other command line thing. So in either one of these, you get basically, a place where you can type code. So in other words, and I don't know if we're getting too far ahead when we say variables. Let's just say I had integer 1, and I said that was 5, and then my integer 2 is 6. And then the simplest thing might be to add 2 things together, and we'll see that, oops, not 6. Type correctly, the simplest thing is maybe just add 2 numbers together will give us the correct result. So, this, which we can get into, is just storing a variable, creating a variable, storing a value in that variable, making 2 of them, and then adding 2 numbers together. So 5 plus 6 being 11. You can see the same would hold true in our other editor, which I'll just do something similar. And I don't know if these share a space or anything or not, but either way I'll be reassigning them. 1 plus my 2 is 5. Okay, so simple. So now just the whole point was that is just you understand that you can type the code in either manner. Similarly, we could, if we wanted to, you could make a file out of this, say, let's just say, I'll call this MB, and the extension is PY for Python files. So if I just make a file called mb.py, that's my initials, that's all that is. You can see it's already associated, it has the Python icon on my graphic for my icon for my file. And I can say edit with idle. And basically I'll probably get another one of these that'll come up. And I could do something similar. 1 and 2 equal 2. I have to remember. Okay, before we do that, let's start with nothing. Let's say we have an empty file. So before I get to that, let's go to our website that has the actual content. So this book, I think, is really good. So it's, like I said, it's written by this guy, Al Swigert. It's all Creative Commons stuff. It's available everywhere. You can get it in the system. And the first, so chapter 0, as author calls it, introduction. I'm not going to read this whole thing to you, but it's very good for anybody starting out, because it's kind of like, why would you even want to learn this language to begin with? Why would you even want to learn programming to begin with? Like the author says, this is a beginner's book. It's meant for, it gets pretty advanced pretty quick, but it's meant for anybody that's just starting off with Python programming. So some examples, thought there was something on, you're not too old to learn programming. It's another good little piece right there. And then kind of, yeah, basic overview of his entire book. And I thought there was some, what you can do with it. Okay, so download and installing, we kind of went through that already. The interactive shell. Okay, then yeah, and some other places to find help. So maybe we'll go ahead and jump into the first, actually, before we get to the first chapter, maybe helpful when you're looking at this website to, when you're looking at, there's one really good one with like, it was organized, a lot of them really. If you look at any of the jump ahead to any of these chapters, you can kind of scroll around, and anytime you see something that says like project, the word project, or usually at the end they have something like some suggested projects after you've, project, backing up a folder into a zip file. Could be very helpful. At the end, they usually have practice projects. So this one, okay, select a copy, write a program that walks through a folder tree and searches for files with a certain extension and copies them to the folder. We have tons of little examples like this, like that immediately. Okay, that could be like a really good way to make sure that you back up all your files or something like that. Delete all unneeded files. Basically, if you've done the chapter, you should be able to do all these things. Delete unneeded files. Write a program that finds all files with a given prefix, and locate gaps in numbering, and remember all the later files to close this gap. That would be good. Now, in many of these examples, you can think like the point here is that if you, let's take this example and say you had a whole bunch of files that needed to be sequential for whatever reason. Maybe you needed to feed those to, maybe there were picture files that needed to be fed to something that's going to create like a video and they have to be in order or something. If you had like hundreds of files, it would take forever to rename hundreds of files. It would take thousands of files. Like it would take forever. Now, the thing with programming and code and programming in general, so here at Python, but we can use any programming code, is that what would normally take hours and hours and hours, once you know how to do it, this can be used to automate a task like that and save tons of time. A couple other really good ones. So, web scraping. There's stuff about like Word and PDF documents. Again, this is just, we haven't even started coding yet, but it's important to understand what's possible with coding. Project, downloading all, okay, so here they used how to download all the pictures from a certain webcomic. But this could be, how to download all pictures from a given website. I know I've had that come up just recently where I need like photos of the library for a project I was going to be working on. And we had something like, I think it's even in here later as a suggested project on how to download all the pictures from a given website. Let me see if it is in here. Let's see, practice project, command on email, ready program that takes an email address and logs into your email account and sends an email to string to the private. Okay, that could be useful. Automatic emailer, image site downloader. That was the one. Write a program that goes to a photo sharing site like Flickr or Imager and searches for a category of photos and then downloads all the resulting images. That would have saved me a bunch of time then, like, scrolling through our Facebook and our Instagram and thing looking for pictures of the library. Link verification, write a program that attempts to download every link on the page and flags any page that have a 404 and prints them out as broken links. Maybe you have a website and you just want to know if you have any links that don't go anywhere on your website. You can write a Python program that will do that for you. Tons of examples, like, I won't go into too many more, but there's, there's one about, working with Google Spreadsheet, creating spreadsheet documents, creating PDFs, parsing Word documents, CSV files, JSON. There's so many different applications, but I guess before we get ahead of ourselves, we'll go back to, we talked about the introduction, we'll go to chapter 1. And let's see, so, all right, so, okay. So it starts with simple things. So here author suggests going to just the regular shell and understanding that Python can do arithmetic. So in his case, it says try typing 2 plus 2. Program comes with the correct answer. So nice. That's kind of interesting, but that's we got to start somewhere. So okay, so we have this, and we have operations, math operations, which you might not remember, but they should be fairly familiar. You'll see star star a lot of times, or instead of like the caret for exponents, modulus, integers, and division. Yeah, so this one might be kind of important to remember just because you might not have to do that much, but when it comes down to that, you can always refer to the documentation later on, like, how do I get just the remainder from, how do I just get the, like, you know, the first part of the division? So now we have a bunch of examples of numbers, which is probably uninteresting to most people, but just understand that Python can do math. Let's see, some examples. Okay. Oh, and you know, you can't do, you know, you have to fill out the whole code. So if you just do 5 plus nothing, it's going to come up with an error. 5 plus hello will come up with an error. We'll kind of talk about that in just a few minutes here. Okay, so examples of, so now the main types of variables that we're going to use are basically strings and integers, and sometimes float integers. We're going to have like lists and tuples and dictionaries and all kinds of stuff later, but for at least for singular data types, these are probably the big three. So integers, just numbers. They can be negative, they can be signed. Floating point numbers are like decimal numbers. There's sort of a weird thing with Python with dividing and stuff getting rounded not the way you think it is. So if you have some program that's going to do something with decimals, say it's like a finance thing, or like just, I don't know, you're calculating gas mileage or something, and you know, I went 150 miles and I used 3.5 gallons of gas or something, and what was my gas mileage? It's going to be some kind of a fractional number. It's, you know, going to have a decimal in it. So if you think you're going to have a decimal, just use floating point integers, floating point numbers. I should say, just designate it as a float, which hopefully we'll have some time for some examples. Okay, strings. Remember this. Author says pronounce STRS as stirs, but I don't know. In my head, I always just think strings, like STR stra, but as strings, I guess. Okay. All right. So catenation replication with strings. So now we've already demonstrated numbers can be added together. Strings can be added together too. So you can say, let's say Mike plus library, and you'll get just Mike library or something. This is helpful later when you want to print out, you know, an output of some sort that just says like the answer, like you know, something that the user would read, and you want both strings and possibly numbers or something. And so you might want to say print out a line that just says, in our gas example, says your gas mileage was 34 miles per gallon. Basically, you're going to have a string that says your gas mileage was, and then you're going to have, you know, the number, which was probably calculated by math earlier, and that's going to be one string that we're going to print out as a line, which hopefully we'll get to in just a few minutes. Okay, Alice times 5. You can see if you do a string, you can do multiplication on a string. You can do, well, a string times a number. So if you do Alice times Bob, kind of, I wouldn't even understand how that would work. So of course you're going to get an error, because if you can't think of what to do, the Python interpreter is probably not going to know what to do either. Okay, so storing values in variables. This is good. So now we're getting somewhere. Okay, so all right. So in this example, and I'm just running some of the simple examples right off the screen here. Let's say we had a variable called I don't know. Let's say items in a grocery store. Let's say. Okay, so we have apples, let's say we have 6 of them. And then we have bananas, and we have 7 of them. How many items are in a grocery cart? You could say apples plus bananas, and hopefully we'll have the right answer. So 13 items, right? This is the method of assigning a value to a variable. Basically, you give it a name. In this case, I just made up the word apples. Now, apples is a variable that I've created, and I assign it the number 6. So it's an integer. Same with bananas, and basically what's happening is we're adding an integer plus another integer and getting the number. I could say, you know, items in cart is equal to apples plus bananas, and it didn't print out the number for me, but if I then ask, you know, in cart, it'll tell me the number is 13. So this is good. So this is kind of quickly how you can kind of assign variables and have that created by other variables. So let's move on. Let's see, variable, I wonder if I should do maybe a side-by-side view would be more helpful. Move that over there. Okay. All right. Of course, you can assign strings to variables. So a quick word about variables. There's certain things you can't do. Now here, all I did was when I make my variables, I just do a lowercase alphanumeric characters. So certain things you can't do that keep in mind, and Python will give you an error if you did any of these. Can't do hyphens, can't do spaces because space kind of means another command. Can't start with a number, can't begin with a number, I should say. Total sum, okay. And then there's sort of another thing. Now there is a style guide, so, and I don't remember what the style guide actually says about, you could probably look up Python style guide. But to me, it kind of makes sense to either do, you know, like items in cart by itself, all lowercase stuck together. There's another thing where sometimes people say do items underscore in underscore cart, and that's fine too. And then there's sort of another thing where people will say to do what they call a camel case, which would be like items and cart all stuck together, but capitalized words, you know, capitalize the first letter of each word in your variable. And honestly, I kind of use them all at some point. As long as they're consistent in your code block, I think you'll be okay. And case-sensitive variables. So if you start doing all lowercase, make sure you continue to all lowercase. And if you start doing camel case or something, make sure you continue doing that. So, okay, so first program. All right, this is good. So now we'll be starting. Okay, so what we want to do here is we're just going to stop at this first line here. So I print word hello world. Programming languages, they always start with having you do a hello world program, and rightfully so. So the print command, you can probably guess what is it going to do. It's going to print the same thing back to me. So in this case, I say print hello world and enter. And now I come up with a little line. It says hello world. Great. Let's go back to our file that we were looking at earlier. Now, I can take this file and edit it, and I can print the same command. Let's say I just say print. So get a message in front. Hello world. Okay. Now I can save this, Now it's saved, in my Python file. I did it again, and it should still be there. And then what you can do is say run from here, which is basically the F5 key. So if I just hit F5, oops, it came up kind of quick. We'll do it again. So if I hit F5, another window will come up, and it will run the code, which will basically say, hello world. This is great. Now, let's backtrack again. And when we're talking about the environment variables being set when we did our install for Python, now here to get here, all I did was launch the command prompt, which is just type CMD and you get to command prompt in Windows at least. And normally, so now because that thing was added to the environment variable, that means that I can call Python from the command prompt anywhere. So in other words, if I just type in Python, it launches Python, just like the shell that we were kind of showing from the start menu earlier. And this is just super helpful because you have to remember paths and stuff, and it's just easier. Normally, now if we didn't have that in the environment path, this would give an error when we type Python because, let me fix this. There's not an actual Python executable file in this directory. So type Python and it'll launch Python for us. Now what we can do is, and for whatever reason, I guess you have to type Control-Z to get out of that prompt. What I can do is I can go to where that file is. So and this is maybe beyond the realm of this discussion, but I just did CD for change directory, and then I went to the desktop because it's on my desktop, and then here's my file that I just had a minute ago. So what I can do is I can type Python and then the name of the file, and it will launch the file. In this case, all we did was tell it to say hello world, and then it says hello world. So great. Now also later on, we can build this into, like, if you write in a Python file, you're probably thinking like, oh, okay, you're just typing a bunch of stuff into a command line editor. Like, how is it going to interact with anything, ever? Once the file is done, once we've made it do something, we can then launch that anytime we want by invoking the Python command and then the name of the file. Also, this could be compiled into an executable file later on, which I don't know if we'll have time to demonstrate, but this can become an executable file if you wanted to, say you wrote a program that, I don't know, does something, maybe it was a game or something, and you just wanted to share it with someone, and you wanted to take it to another computer. Well, you can compile that into an exe and then put it on a flash drive, put it on somebody else's computer. They would just launch the executable file, and it would come back. In our case, it would say hello world on the computer, which is really boring. But if we made something cool, like some utility that maybe backs up a bunch of files or does something really useful or combines a bunch of PDF files or parses a bunch of websites and things like that, then it would be cool. And that's how that can be shared, and that's how this is going to become useful. So let's go back to where we were here. Okay, so print hello world. So we got it. Now we got hello world. This is great. We've started somewhere. We've already created a program and launched it and everything. I have some examples here to kind of demonstrate more things. Yeah, I guess we could do that. So here, author suggests put another statement that says, "What's your name?" And they also have, the little hashtag symbol here, which is comment. It's helpful to comment code, especially when you think that no one will ever have to read the code again. And if anyone did, it would be you. But at some point, you'll discover that reading your own code is later on you'll be like, what the heck was I thinking? What was I doing? So it's helpful. Here, author says, ask for their name. Okay, that maybe starting off that would be helpful. To me, it's kind of like, it's going to ask for their name because the string is what is your name. So to me, it's kind of okay. Well, that's just you're adding more text to something that doesn't need to be there, but we'll do it for this one. Okay, so next, this is probably good. We will go through this one. So author suggests maybe making a variable called my name and assigning it the value of, okay, input. So this is a function that's built into Python. You can tell it's a function because it has these two left and right parentheses here. So it's a function, and input is a function that is already in the Python library. Not sure how deep to go into that, but we'll find out what it does very soon. And we'll find out probably on the next line. So next we'll say, okay, print something that says, nice to meet you. And remember we talked about, let's maybe even do, we'll say print the name again. So print my name. Okay. Now what do we think that's going to do? So I'll hit F5, we'll compile this and run it. Not really compile, but okay. So it ran my hello world line, and then it asked for a name. And the input is basically, the input function basically says, sit there until somebody types something. So I'm going to say, Mike, and I'm going to hit the enter key, and then it's going to go to the next line. So I printed my name again. Nice, okay. Now, if I go back and I say, instead of printing my name, print something that says, nice to meet you. And put that in, I don't know if I mentioned that, but at least the print command is basically, probably should explain that. So the print function, what the print function is doing is, especially in our hello world example, is you can tell it's a function because it has two parentheses, and inside the parentheses is what's called the argument that gets passed to the function. So in our case, it's a string, and we know it's a string because we enclose it in two little single parentheses. And basically what it does, you already saw it, it prints out hello world. It just prints it out on the output of the program. So here we take this again, we say print, nice to meet you, and we're kind of talking about it's possible to add strings together later. So you can say plus the name of the variable. So the print command can take strings, and you can add variables to it. So in our case, we're adding a string plus a string, which is something that Python understands. Anyway, short story is, launch this again. What is your name? I'm going to say maybe my name is Alice. Nice to meet you, Alice. Now I forgot a space in there, but you get the idea. Fixed. Save. Okay. All right. And now the author suggests we can use another function that's built in called the length variable. So what the length function, what the length function does, and it's just len, so length, and you can give it a variable. So in this case, my name. So whatever name gets supplied via our previous input function is going to get calculated by this length function. All it does is, it's another built-in function. It just calculates how many characters are in the variable. Really basic. So what we can do is we can wrap that up into the print function. This is sort of how you can nest things together. So now we have, two sets of parentheses. So you have, the length of my name, and then you also have the print function on that whole thing. The end result is just that it should print out the length of my name, if I did it correctly. So let's run this again, and let's say my name is Bob. Nice to meet you, Bob. And the number 3, because there are 3 characters in the name Bob. Great, we're already kind of figuring out how to use built-in functions and how to nest functions together. This sort of gets important later when, strings and different variables get added together. You can convert integers to strings and things like that. But there are certain cases when it's going to give an error, and you sort of have to remember to, if you're going to print it in the print statement, for example, that you have to convert an integer to a string if you're going to use it in the print statement or something. Various weird examples like that, which I'm sure we'll probably find out in the next few minutes here. Okay, so length of your name is this. I didn't write that line because I don't think it's important, but what is your age? Okay, so here's where it'll get really confusing. So we'll do this one. So let's see. In fact, maybe we'll do, okay, so he did this on 2 different lines. I'm gonna fix that really quick and say the length of your name is, and just so that looks right. Just one extra, and I even typed it wrong, but it doesn't matter. Just one extra line. So author then says, try doing, print another one. What is your age? Age. And he has a little comment that says, ask for age. Why is this not, oh, there we go. Of course, syntax being important. Single quote, not a double quote. So print what is your age? And again, we're going to make a variable. We're going to call it my age, and we're going to ask for input. We're going to ask the user to supply that variable straight from the command line. At this point, it would be asking and waiting for me to type something. Print. Okay, so this is where it gets crazy, right? So trying to think of the easiest way to, I could just type this whole line out or copy and paste it or something, but it would take the fun out of it. So you will be, let's see what will happen if we do, you will be, and I will add that to my age, and we'll add that to in a year. Can't remember if that'll give us an error or not. So, what is your name? I'm going to say it is Charlie. And my age is 10. It will be 10 in a year. Okay, I guess that did work good. But the author here has done, okay, so let's start from the inside out. So my age, we understand, is going to be the variable that was supplied. In this case, it was the number 10. I think this kind of converted something in the background for us, but let's pretend I didn't do it this way. Maybe even we'll take out this string. Let's say I was going to print just my age. In fact, maybe even start over. And let's just say my age is 10. I don't even need the rest of this, right? Print my age. In this example, you can tell it's going to print, it should print the number 10, which it did. Maybe even let's get restart shell, get rid of all this. Let me clear the screen. I don't remember. Well, I guess I could close the shell and run it again. That would do it. It did do it. Okay. So, okay. So in this example, this guy's saying the integer of my age plus 1. This is like converting it to an integer if it's not already an integer, because in our previous example, now here we just sent it to an integer, but before it was a string. Probably should have deleted that. It would make more sense. This would give us the number 11 because you're adding 10 plus 1. Wish this would give us an error, but it's probably not going to. Okay. Yeah, Python's really friendly. It also says to wrap this up in a string. I think Python 2 didn't work this way. I think you had to implicitly convert this into a string first. And then now this looks like just way too much code for no reason. But you're basically saying, take the integer value of my age plus 1, which is 11. So make it an integer and then convert it back into a string. And then because normally the print statement would like a string. Hopefully another example will trip us up and it'll become more apparent. But as you can see, we pretty much ran through all of this and it wouldn't have any problem. Okay, so that's what's happening there. And actually, just to, if I go all the way back, so still, you know, we could run this from command line too. And then we have, oops, 11, oops, maybe if I save it first, file, save, and then run it again, and we'll have our little like name length creating thing. My name is, let's say it's David. Length of the rename is 5, and the age, I kind of skipped the part that asks for that. Okay, comments we talked about already, print function we talked about, input we talked about, length function we talked about, string and float. Okay, I am. Yeah, so here's where they kind of talk about converting different types of values. In other words, if we go back to interpreter here, the shell, I should say, you'll kind of see some interesting things. So when we're talking about an integer, is just an integer, like a whole number, positive or negative. Float is going to be a number with a decimal point on it, and a string is just a string, bunch of characters, alphanumeric, whatever. Now, when we do say, you can convert a number to a string. In this case, author says try converting 3.14 to a string, and it says the value of that is just 3.14. What gets weird here is when you say convert. Now, the number 1.25 is a floating point number, so it's a decimal number. But if we say convert that to an integer, the integer value is going to be like 1, because we told it to just make it a simple integer. What gets weird here is in the next example, glad this is here, and we say integer of, say, 1.99. One would think that this would get rounded up to 2, but that's not how it works. It comes back with 1. So that's why, as we were saying earlier, it's important to use floating point numbers when you're expecting floating. If you're going to expect a float, use a float, because you'll end up with weird, like, rounding things later if you don't do it that way. And some of these can be interchanged, but that's one example where that will cause a problem. Text equivalents. Okay, so now we're going to be talking about at this point in this book, we've kind of stopped talking about assigning numbers and things. Now we're going to be checking to see whether something is something, which is the 2 equal sign operators. I think there's a chart coming up that will make that more apparent, and here's a kind of long explanation of the process behind, which I thought was like that really long string earlier, how that gets evaluated all the way down to a single string. We could do some of the practice questions. I may have put you to sleep, but I'm wondering now if we should go with the practice questions or just move on to the next chapter and look at something more interesting. And these are just questions, name three data types. Okay, what would happen here? Yeah, we're going to move on because there hasn't, normally at the end there's kind of a suggested project to like write a program that does this, but we haven't really touched on a whole lot yet, so let's see what happens next. Next chapter is on, we only have about 10 minutes, so we'll be cruising here. Flow control, okay, so you're going to be probably talking about if statements and things. Here we have a basic flow chart of kind of what would happen in the logic of a program. These are nice to kind of plot out what the overall flow of a program would be. When I was in college, I had a class where we had to do a chart like this before we even like touched a key on a keyboard somewhere. Actually, we did it in Visio, but we had to create a flow chart for our program before we could even go to program the program, which seems backwards, but it's important to kind of have the flow control. This is like kind of by hand writing out what you want your program to do. In other words, if you had a program that you wanted to, calculate your grocery bill or something like that, you might have a thing, okay, like you would write out like, okay, I'm going to calculate how many items are in my shopping cart and how many of each type. And then I'm going to calculate like, the price of an apple times how many apples I bought. and all those, and then I'm going to go and then add up all that, and then I'm going to calculate like whatever the state sales tax is for food and whatever the county tax is for food. And you know, if it's a certain type of item, you might get taxed differently. So this is where, you know, like having something like this diagram for your program would be helpful. And it actually does make it easier to write the code a lot of the time. Okay, so Boolean values. Okay, so true and false. Yeah, not much other to say than there's the values true and false exist. So you can check to see whether something, if a condition is true, then do something. If a condition is false, then do something else. This kind of leads into the if-then operations and different kinds of iterations and things like that. Well, now we have comparison operators, which I wish I would have showed us this before they did it in the last chapter. But so these are kind of normally what you would expect. This is like, you know, comparing like if number of apples is 6, then we probably have a bag of apples or something like that. You're just basically comparing one thing to another. It's a comparison operator, or in this case, they call it relational operator as well. The important thing here is to remember that the equal sign is confusing at first. Now, if I say apples equals 6, right? Now I can ask the computer, does apples really equal 6? Now if I type apples, it'll say 6, right? Does apples really equal 6? Which is 2 equal signs. We're comparing it. And it should say 6. It should say true, because I'm asking it. This is a kind of a question, essentially. It's important to note that the single equal sign is not asking if it equals 6. The equal sign is a assignment operator. It's usually a really good example, and I don't know if they do it in this book or not. And I kind of would have to think for a while to formulate it, but you can confuse yourself easily with that. So, and then the not equal is simply the not simpler, the exclamation point right in front of it. These guys over here. So most of the rest of these, okay, good. You can see some examples here. You know, yeah, you could ask simple things like this: 42, is that equal to 99? No. My number of apples equal to 7? No. Is my number of apples equal to 6? Yes, it is. Is my exact equal to, if I was to true and both sides are the same, not equal, okay. You go through some of these examples, but I think most people will probably see what's going to happen here. Except for maybe this one. Yeah, an integer, you know, a float with a bunch of dot zeros after it is still going to evaluate to the same as the integer version, because 42 is really the same as 42.0. 42, but a integer will not equal a string. So a string, because it's got these single quotes around it. So equal to a string value, yes. Okay. Wish I would have came to this page just a minute ago. Okay. Yeah, as we said, a double equal sign asks whether two values are the same, and the single operator is an assignment operator that says make this value equal to this. All right. And okay, so yeah, and then we have things like and, keywords like and or and things like that. I think you probably understand what that's doing. It's better to kind of see a lot of that stuff in an example. Yeah, so here's a couple examples. Like, you know, I won't even type these really, but you can kind of get the idea. You know, is 4 less than 5 and is 5 less than 6? They both have to be true for this evaluation to evaluate to true. Is 4 less than 5? Is 9 greater than 6? Well, 4 is less than 5, but 9 is not less than 6. So the whole thing comes back as false. Is 1 equal to 2 or is 2 equal to 2? Well, 1 is not equal to 2. 2 is equal to 2, so you have true. Probably what you would expect. This becomes important later in things, which should we have more examples? Okay, yeah, so here you have a simple, well, we're running out of time. I guess we'll do this example and then see what happens. Okay, let's go back to, we don't need that anymore. Your author suggests saying, okay, let's have a name of, we'll give it different variables. Let's say, name is Eddie. Password is, say it's library. Okay. Name is equal to Eddie, then do this. So now we've kind of introduced a new thing, which is an if statement. So the basic syntax for this is if the condition is true, do one thing. And I'm just typing this out so you can kind of see. And I'll put maybe as a comment, if yes. And then you have, actually, it should be do one thing. And then else needs to be, well, we have nested. Let's follow their example first. Okay, if name is Eddie, then print hello, Eddie. Right. Then we can do else. Say print hello, stranger, I guess. I even don't fully remember if I need to fix indentation or not, but we'll find out what happens. Hello, Eddie. That was quick. Name equal. Oh, because I've already set it to Eddie. Well, so yeah, if I said Frank, this would probably be better made an example with like the input function that we were using earlier. This probably would say hello stranger instead. So here we are, hello Eddie, hello stranger. So I'm gonna wrap this up because it's an hour class and probably everyone that either was part of this or that will view this later in life will be completely bored. But it's really cool. You can do a lot of stuff with it. I've done many different projects with it. Simple. This works good with like small electronics to like Pi stuff. Raspberry Pi stuff works good with that. You can do all those examples we were talking about before. You can write code that goes through like scrapes websites and things like that. You know, pull out of. You could say like pull all the names and phone numbers and email addresses out of every website on a certain web page. You can see how that would be useful if you're trying to make a mailing list or something, or you're just trying to make a list of phone numbers or something like that. To go over regular expressions, dictionaries and lists and all that stuff is something that would happen later. Controlling the keyboard and mouse with GUI automation, that's pretty cool. That's, you know, you can tell your computer to move the mouse around and click on stuff for you. You could essentially make it like if you're playing like I don't know if they still have like flash games on the internet, but you could tell the computer to basically like play the game. You could cheat everything to have your computer like do everything perfect and get the high score for you. You could do launching programs, keeping time, sending email, text messages, manipulating images. There's so much literally that can be done. So I don't know. So I recommend this book. This Automate the Boring Stuff with Python. Not only because it's a great book, and not only because it's reviewed excellently everywhere, but because it's completely free online. So yeah, here's some more examples. Search for text in a file. Of course, multiple files would be more important. create, update, remove, rename folders, search web content, update Excel spreadsheets, split PDFs and reminders, fill out online forms. That might be a good one. You know, if you ever had like a whole block of data and you need to like fill it into like some form on a website, you know, rather than like typing everything, you know, like you have like 1,000 things you need to put into a special form on somebody's website that only accepts it that way. You can automate that. That would save tons of time. So I guess that's about all that we have time for today. But I guess that's it. If you don't have any questions, I'm going to stop sharing my computer and I'm going to turn off the recording as soon as I can find the button for it.